Go. So it says, the first one says here, a study of elite distant runners found a mean body weight of 63.1. So I'm going to come in here and put 63.1 right there. That's going to be my mean, okay? And then my standard deviation is 4.8, so I'm going to add 4.8 to 63.1. And so 67.9. And then to come down, take 63.1 and I subtract the 4.8. So it looks something like that, okay? Now you can see it. All right, so use the 68, 95, 99.7 rule to find the proportions of runners whose body weight is between 48.7 and 67.9. Okay, what's that rule called? Empirical rule. Okay, perfect. So we're looking at from here to 67.9, which would be about here. Good thing that tells me I did everything right. So we're looking at this. Okay. So we could use our calculators and find it really quick and easy, correct? Yeah, it would be a lot easier, but they want to make us suffer. Okay. So if we know that from here to here is 68%, that means that this one little section right here is how much? No. This guy right here. That's 34. How do I know it's 34? Perfect. 68 divided by 2 is 34. Okay. So we know from 2 standard deviations that that is 95, correct? But we've already accounted for how much? 68. So I need to take the 95 and do what with it? Minus the 68 and divide that by 2. That means that each of these little sections here is at 13.5. Okay. That means that this little section right here is also at 34. This little section right here is at. All right. Everybody with me how I've gotten those numbers so far? Okay. So the last one is 99.7. But what I've already accounted for? I've already done 95% of the data, so I'm going to take 99.7 and subtract 95, which gives me what? Well, it gives me 4.7. Divide that by 2. It gives me 2.35. We're still on the same page. All right. So let's add these 3 numbers and then that number right there. And that should give us our percent. If you're going to leave it in decimals, leave it in decimals. So I get that. Questions? All right. C, I'm going to do my normal CDF. Below 60, so that means that my lower bound is going to be negative 1E99. Upper is going to be 60. My mean was 63.1. My standard deviation was 4.8. And if you put that in your calculator, you should get that. Now, does anybody need any help on their calculator part? They're all quiet. Okay. So then what proportion of runners have body weight above 70? So that, again, I'm going to go with the normal CDF because I'm looking for the proportion. But this time, because it's a right tail test, my lower is going to be 7. Upper is going to be 1E99. The mean is 63.1. Standard deviation is 4.8. And my calculations gave me 0.0753. And if you did it with using a table, I can work with you individually on how to find it using a table. Questions? Sweet. Now this time they gave us the percentile. So this time I'm going to go with my inverse norm. Okay. So area is equal to 0.45. Mean is 63.1. Standard deviation is 4.8. And I get 62.5 kilograms. Area is the percentile, 0.45. And we got to be careful because there's on our next assignment, it's going to talk about upper and lower. So you got to be careful what percentile you're actually looking at. Okay? Okay. Let's see if we can wrap up 2 and 3. 3 will be like 3 seconds. All right. Find the proportion of observations. Sketch the normal curve and shade the area under the curve. That is to answer the question. All right. So I know everybody's super jealous. Okay. So notice how this was like negative 1.51 and it's 0.84 and it has this magical word right here. Standard. Sketch is another magical word for Perry. So we're going to put, when it says standard, I know that my mean is going to be 0 and all my standard deviations are just going to be counting by. Perfect. So it looks something like that. Okay. Then, you know, negative 1.1, sorry, let me read, negative 1.51. So I'm going to say that that's right about here. And then 0.84, I'm going to say is right about here. And then I'm going to shade this in. Okay, so then that's our sketch. Sketch the normal curve and shade the area under the curve. That is to answer the question. Done. Except for my shading part. Okay, what z-score in a normal distribution has 33% of all of it? Okay, now this is what I'm talking about. What z-score in a normal distribution has 33% of all scores above it? Okay, so if I was to think about this with you guys, yeah, it's got to be what? Yeah, because the 0.33 is going to be something like this, right? And so that's a right. If your calculator actually has the right tail test, you can just go. So if your calculator tells you that it's a right tail test, when you do that inverse norm, you can just do the area as 0.33 The mean is going to be 1, standard deviation is 0. But if you don't, like my calculator, I can't do it. So I have to change my inverse norm. My area's got to be 67 or 0.67. The mean's got to be 1, and the standard deviation's got to be 0. Okay? That's just something I have to do. So if your calculator, when you, I think the yellow ones over there in the suitcase, they'll actually have the right tail, left tail, and you can actually change it that way. Okay. Yep. You're right. I got to switch that around. I got too excited. I got 44. That's what I get on mine. On you do that right tail test. Is that what you guys get? Okay. All right. Perry's happy. Everybody's happy. Okay. Except for Luke. Luke's not happy when Perry's happy. All right. Real quick. A normal probability plot for the amount of lactic acid in a sample of 30 pieces of cheese is shown below. Is the lactic acid distribution approximately normal? Justify your answer. Is this approximately normal? Why?